Okay guys, here we go, multiplying fractions today. We got quite a few examples today, so hopefully we can get through these pretty quickly. Let me make this a little bigger for us, and then we'll get started on answering our questions. Alright, multiplying fractions is what we're going to do today. First I'm going to start with our modeling. So how you're going to draw them, you are going to have to do some modeling, so pay attention to how I do this. When I model this, guys, all I'm going to do is I'm going to start by drawing a square, because we're using our area modeling. So this is an area modeling technique. Now the next thing I'm going to do is I have my denominators of 5 and a denominator of 4. So I'm going to break my squares into my denominator numbers. So I'm going to do 5 going, I'm going to do 4 going down. So I have 1, 2, 3, 4 there, and then I'm going to do my 5 going this way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That was interesting in what I wrote and what I said there. How about that? Okay, so now I'm going to shade in. So for the 1/4, I'm going to shade in one of them. So I'm going to switch my colors here so we can see a little better. Try to make my pen a little thinner. Alright, let's use red for this. And I'm going to do 1/4. So that's just one of the rows. I do the entire row. So I'm going to go across. I'm going to do 1. Okay? And then I'm going to do my 3/5. I'm going to pick a different color. Let's do purple. Okay, and for 3/5, I'm going to do 1, 2, 3 of them. So for 3/5, I'm going to do 3 of them. I'm going to go down. There's 1. There's 2. And there's 3. Now for multiplying, it's pretty easy. What I do is I look. Let me go back to my blue pen. I look for my overlap. So I can see that right here I am overlapping. So I have 3 that are overlapping, and then I count how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 3 out of 20, and that would be my final answer. 3/5 times 1/4. So in this one you are looking just for the overlap when you make your grid. Okay, moving on to example 2, so I'm going to slide down. In example 2, we're just going to do some multiplying fractions here. Multiplying fractions is relatively simple. You're just going to do numerator times numerator, and that's going to be your new numerator, and then you're going to do denominator times denominator. Okay, and then as always, you can simplify or whatever like that. Now, there's 2 ways of doing this problem. You can simplify actually before you multiply, or you can simplify after. This only works for multiplying fractions. So let me show you without simplifying first. So I'm going to do 3 times 11 is 33. 5 times 12 is 60. I have a negative times a positive, so I get a negative. I can reduce those. I can divide them both by 3. And I am going to get negative 11 over 20, which is the right answer. Okay. Another way I can do this problem, and I'll show this one in red, is I can do what we call cross-canceling. And cross-canceling means I'm going to simplify before I multiply. To cross-cancel, you compare the numerators with the denominators. Now with multiplication, I can do any numerator with any denominator. So for example, I can cross-cancel or reduce the 3 and the 12, this 3 and that 12, even though they're not from the same fraction. So what I'm going to do is I'm going to divide them both by 3. 3 divided by 3 is 1, so I cross off the 3 and make it a 1. 12 divided by 3 is 4, so I'm going to make that a 4. Now I can multiply across. Okay, 1 times 11 is 11. 4 times 5 is 20. Negative times a positive is a negative. And I get the same answer, but I can do my reducing first. And a lot of times cross-canceling, it's not necessary, but it makes the problem a lot easier to multiply. And since you can't use calculators, it makes much smaller numbers to multiply. Okay, I'm going to go on to my next page, so if you need to pause, go ahead and pause. Move up. In my next page, we're going to do multiplying a mixed number and an integer. Go back to my blue pen here. So to multiply a mixed number and an integer, I have a word problem here. A recipe for 1 loaf of bread requires 3 1/4 cups of flour. Joe wants to make 15 loaves. How much flour does he need? Well, I'm just going to take my number 15, and I'm going to multiply it by 3 1/4. Here's the deal. When you multiply with mixed numbers, guys, you have to turn them into improper fractions. Okay? There are ways of doing it without that, but they're much more complicated. So for our class, I want you to turn them into improper fractions, which means 15 is going to turn into 15 over 1 times 3 1/4 is going to turn into 13 over 4. Remember, I do 3 times 4 is 12, plus 1 is 13. I cannot cross-cancel, so I'm going to have to multiply these out. 13 times 15, well, if you can't do that in your head, then you just do it out the long way. Okay, you're going to get 185, but, 195. But here you go, you do 15 times 13. That is 5, carry your 1, that's 3, that's 4. Then I put a 0 here, that's 5, and that's 1, and you get 195. You can barely see that there, but there it is. So you get 195 over 4. Okay. Then I'm going to turn that into an improper, or back into a mixed number. So I see how many times 4 goes into 195. Well, 4 goes into 19 4 times. That's a remainder of 3. Goes into 35 8 times. That's 32. You have 3 left over, so you have 48 and 3/4. Oops. Low cups. Cups. 38 and 3/4 cups. That's your final answer. There is a way of doing a distributive property technique in here, of doing 15 times 3 and then 15 times 1/4 and adding those back together. That works. That works pretty well for when one of them is a whole number. But I just want you guys to get in the habit of turning them in improper fractions, because in the next example that does not work as easily. Okay, moving down to my next example. Multiplying mixed numbers, so now they're both just mixed numbers. So I'm going to turn them into improper fractions. 4 times 2 is 8, plus 3 is 11, so I get 11 over 4, that is negative, so it stays negative. 5 times 3 is 15, plus 1 is 16, so I get 16 over 5. Ooh, in this example I can cross-cancel, so I'm going to switch to my red pen so you can see that. Can't do anything with the 11 and the 5, but the 4 becomes a 1 and the 16 becomes a 4. 4 divided by 4 is 1, 16 divided by 4 is 4. Got to divide them both by the same number. Now I can multiply. 11 times 4 is 44. 1 times 5 is 5. That is negative, because a negative times a positive is negative. 5 goes into 44 8 times. That's negative 8. Don't forget your negative sign. And 4/5. Really important that you don't lose track of your negative signs when you're working on these problems. Okay, and that is your final answer. You can see clearly on this one that I cannot do negative times 2 is negative 6. 3 times 1 is 3. 4 times 5 is 20. That does not equal the same answer, so you cannot do that. You have to turn them into improper fractions. Okay, I'm going to move on to my next example. If you need to pause, go back to my blue pen here real quick. Okay. Sorry. In example 5, and this happens to be the last example of the day, simplifying the expression. In order to simplify the expression, you're going to go through the same process. You can cross-cancel. So in this case, I have the 10 and the 5. I can't cross-cancel. 5 divided by 5 is 1. 10 divided by 5 is 2. Okay, so I can cross-cancel. Then I can multiply across. Well, I have no whole number, so I have no whole number on top. Except for 1. 1 times anything is going to be itself, so that won't be written. But n squared times n to the 3rd power. Remember, side note, from last chapter, if I have n squared times n to the 3rd power, you add them, that's n to the 5th power. Okay? Because this means I have n squared times n to the 3rd power, which means I have 5 of them. So that's n to the 5th power, a little reminder from last chapter. On the bottom I have 2 times 9, which is 18. I cannot do anything else. That is my final answer. N to the 5th power over 18. That is it for tonight, and we will see you tomorrow.